Storing energy efficiently, not just for hours or days, but for months. That's what a new system from Switzerland promises, and all of it with almost zero loss. And it all uses conventional caustic soda solution, which is, for example, also used to clean pipes. How this works, what potential this thermochemical storage system has, and how it's being used in an initial pilot project in an older building here in Germany, we will find out today. And with that, welcome to the German Science Guy. I'm Dr. Jakob Beautemps, and in Germany we say Los geht's! On sunny summer days, there's often a surplus of solar power. At the same time, households typically use the most electricity in the mornings and evenings, precisely when the sun isn't shining strongly enough yet or has already set. In winter, this problem becomes even more acute. There are fewer hours of sunshine, energy demand rises, and heat pumps require additional electricity for heating. Although a heat pump is very efficient, it has one major drawback. It requires electricity precisely when the demand for heat is highest and solar power production is lowest. That is especially in winter. As you can see, the whole problem is very complex and very deep, and we do a lot of research behind it. And behind each of our videos lies weeks of in-depth research. For some of these steps, it helps to use AI, for example, to get an initial overview of a topic. But of course, we always verify everything in detail and examine the original sources closely. This channel is and will always be mainly run by humans with human brains, and all of my team members have a background in science. But for certain steps, AI simply helps speed up the process. But here comes a problem. In everyday life, for one task you need ChatGPT, for the next Claude, and for graphics yet another tool. In the end, you end up with a huge pile of subscriptions that really add up. This is exactly where the partner in today's video comes in, Mammoth AI. It's an all-in-one AI hub that bundles the world's leading models such as GPT 5.5, Claude Opus 4.8 and Gemini 3.1 Pro into a single clean interface. You no longer have to switch back and forth between tabs. Instead, you can compare your prompts across different AIs with a single click. And instead of spending hundreds of euros on individual subscriptions, you can get the complete package here for as little as $10 a month. Whether it's for school or work, it simply saves a massive amount of time. If you're also tired of subscription chaos, be sure to check out the link in the video description and try it out yourself. But back to the question of how can we store energy more efficiently and how can we do it in a way that we have the energy at a time that we really need it. A new idea in this area comes from the Swiss company Season. The aim is to use excess solar energy or waste heat, for example, from data centers to provide heat for the winter. They do this through a thermochemical process. That's a process in which heat is either released or absorbed. In a so-called absorption heat storage system, energy is stored in the form of chemical potential. The storage medium for this technology is said to be caustic soda, the substance we know from everyday items like drain cleaners, soap, or even pretzels, the favorite food of us Germans, at least in Bavaria, but to be honest, that's a total cliché. Let's take a look at the basic principle of the system to understand exactly what's behind it and what chemical reactions are taking place. There are two tanks. One contains caustic soda solution and the other contains water. If excess energy is produced in the summer, for example from photovoltaic systems, the caustic soda solution is concentrated by evaporating the water and then collecting it in the water basin as it cools. In other words, the mixture is separated by using the energy to evaporate the water and then collecting the water in a separate tank. Over the summer month, the caustic soda solution becomes increasingly concentrated in this way. In winter, this process is reversed. The stored water is now fed into an evaporator. The water vapor then flows toward the highly concentrated caustic soda solution and is absorbed. In the process, energy is released and the solution heats up. This heat is then transferred to the heating water surrounding it and can be used for heating. Chemically, what is happening here is a so-called exothermic reaction. Caustic soda is in fact sodium hydroxide dissolved in water. When it comes into contact with water, more energy is released than is required for its activation. The sodium hydroxide then breaks down into its components, a sodium ion and a hydroxide ion. The released energy is mainly converted into thermal energy, which can now be utilized. If we now look at the process in the summer, we have an endothermic reaction. When water is removed from the mixture, we must supply energy to the system, which is provided, for example, by the photovoltaic system. So the storage system is based on the chemical potential of the caustic soda solution, which is preserved as long as the two tanks do not come into contact with each other. The company sees several advantages in using caustic soda as a storage medium. It is not a critical raw material for which we are dependent on other countries. Unlike oil, gas or hydrogen, it is neither flammable nor explosive, but it is corrosive. I will go into more detail on that in a moment. In addition, the caustic soda system is significantly cheaper than batteries or hydrogen. The company sees another advantage in the fact that high flow temperatures can be achieved through the exothermic reaction. Flow temperature is the temperature of the heating medium before it is fed into the heating system. Generally speaking, with heat pumps, for example, the lower the flow temperature, the more efficient the entire heating system is. But this is also where a problem lies. In poorly insulated buildings, a low flow temperature isn't enough to heat the rooms adequately. And that's exactly where the caustic soda system would come in handy. Furthermore, the season system consumes almost no electricity when heat is drawn off, since it is chemically stored in the sodium hydroxide solution. This prevents buildings from exceeding their maximum power capacity in winter. This is a problem that can quickly arise with many heat pumps and more generally with rising electricity consumption. The technology is already being used in several pilot projects, and in the future one of these projects is set to take place here in Germany, more specifically in Bochum, very close by where I live. The absorption storage heat pump is to be operated in an apartment building with 36 units. According to Season, this is an older building that underwent thermal retrofitting around 2010. The amount of caustic soda planned for the initial phase is approximately 20 cubic meters, and the system has a thermal output of 80 kilowatts. That's quite a lot. A heat pump for about 150 square meters typically ranges from 8 to 12 kilowatt. The storage tank is to be charged using excess energy from a photovoltaic system and electricity from the spot market, that is, a market where excess electricity can be purchased at low price. Since the system is entirely thermal, the photovoltaic electricity must first be converted into heat via a conventional heat pump, and according to the manufacturer, however, the savings are expected to amount to several thousand euros per year. Although spot market prices are of course difficult to predict, but in the past years, actually here in Germany or in whole of Europe, we sometimes even had negative prices because of a lot of solar and wind power. Okay, sounds pretty good, right? But here's a legit question. How safe is a system like this really when it uses such a large quantity of caustic soda? After all, that stuff is corrosive. Sodium hydroxide is first and foremost a highly dangerous chemical due to its basic properties. Depending on its concentration, it has a pH of up to 14, which is at one end of the pH scale. Contact with the skin or eyes causes immediate chemical burns, which can be very severe. That's why we asked the company for more details on what the specific safety measures should entail. The caustic soda must first be stored in a double-walled tank, or at the very least in a tank equipped with a spill containment tray. While a leak is considered rather unlikely, if one were to occur, it would be very bad for the environment. That said, it's important to note that the company already has extensive experience with this type of storage, and such double-walled systems or tanks with spill containment trays are a very reliable solution here. Maintenance is of course also important, but based on current information, it is not expected to be time-consuming. Pumps are designed to be easily accessible and can be replaced without difficulty. A major advantage, however, is that the caustic soda, or rather its chemical potential, does not deplete and can be used indefinitely. So to me, it all sounds great. I'm really excited about it, especially because they try it out close by to me. But of course, we also have to look at the big hurdle that's a part in every of my videos, where I always examine the problems and limitations of a new technology. As always, with sources that I link transparently in the description box. And if you like this and want to support it, you can do so for free with a subscription. And don't forget to turn on the notification bell so you will know when a new video is released. Okay, now here's the thing. I started by doing a quick rough calculation to see how much caustic soda would be needed for a typical single-family home if we wanted to generate 100% of the heat from this absorption heat storage system. Let's assume a typical annual heat demand of 120 kilowatt hours per square meters for a living area of 150 square meters. If the heat demand in winter is 75%, then the storage requirements would be about 48 cubic meters of caustic soda solution, assuming the solution's energy density is 280 kilowatt hours per cubic meter. That would amount to 48,000 liters of caustic soda required. That's quite a lot. By comparison, an oil tank in a typical single-family home holds about 3,000 liters. So comparatively speaking, the caustic soda requires an enormous amount of space. And that doesn't even include the equipment. The company emphasizes that it therefore depends heavily on the building standard and the desired level of self-sufficiency. The technology is therefore intended for use in larger buildings, such as apartment buildings or in industrial processes. According to Season, the payback period, that is the time it takes for an investment to recoup its cost, is estimated to be between 15 and 25 years. The larger the storage medium, the greater the cost effectiveness. However, I cannot say at this point how much such a system will ultimately cost. The claim that it is supposed to be cheaper than batteries or hydrogen comes from the company itself and cannot be verified as such. It's important to note that the source of surplus energy is also required in the first place. If, for example, you rely on photovoltaic system, that system must first be paid off. The same applies to a heat pump if the absorption heat storage system is intended to serve only as a supplement. All in all, the costs for 100% self-sufficiency will be very high, something not everybody can afford, especially because it's a high investment in the beginning and of course it then works for a long time, but you still have to invest in the beginning. And there's one more important point to note here. The new technology isn't quite ready for the market yet, but pilot projects are already taking the first steps in that direction. Like I said, next year it should be ready and it is really close by where I live. So if you want to, I will try to get there and film there. I'm also in contact with the company already, and then we will be able to see more clearly just how expensive and how efficient the technology is in practice. For now, I think it's cool that researchers and companies are working to find solutions for storing and using excess energy in a meaningful way, and doing so without rare earth elements. As we've seen, it's unlikely to be a technology for the general public, but perhaps for larger buildings or in industry. But it could offer a good alternative that doesn't consume electricity during peak heating periods, which is of course also very beneficial for grid stabilization. But there's one more hurdle which remains, and which we also saw recently in my video about the solar park, where I visited one of the world's largest solar parks, which uses liquid salt as an energy storage medium, among other things. The problem is that long-term energy storage isn't actually rewarded. You make money by charging and discharging frequently, because that allows you to capitalize on the market fluctuations. Yet long-term storage is of course sensible and important for the entire grid, but it simply isn't factored into the pricing in our ecosystem. But what do you think? Do you think a thermochemical energy storage system could be the future of energy storage technologies? Feel free to share your thoughts in the comments, and here is a video about the solar park, and I think it's one of my best videos. Not so many people have seen it yet, I don't know why, but if you want to, please feel free to see it, and if you like it, share it. It would mean a lot to me. And I say Auf Wiedersehen, which means goodbye in German, your Jacob.